Hello dear friends, welcome back to my YouTube channel Chemistry Aspirant. Now in today's lecture we are going to learn about the terminologies used in the coordination compounds. We know that the coordination compounds are the chemical compound which consist of anions or the neutral molecules which are bonded to the central metal atom or central metal ion via covalent coordinate bond. So in this video, we are going to learn some important definitions that are used in the coordination compounds. Now here, which definitions and the terminologies that we are going to learn in the coordination compound. So the first one is the coordination entity, or it is also called as a coordination compound or a complex compound. Second is the complex ion. Third one is the central metal atom or ion. The fourth one is the ligands. The fifth one is the coordination number. The sixth one is a coordination sphere. The seventh is the counter ion, or it is also called as an ionization sphere, and the last one is the charge on the complex ion. So these are the 8 terminology that we are going to define in this video. So now let us consider the first terminology, that is coordination entity or the coordination compounds. Compound in which the central metal atom or ion, that is the coordination center, is bonded to the anions or the neutral molecules generally called as a ligand, are called as a coordination entity. Now here I have taken the 2 different examples. Here you can observe that there is a one central metal atom which is surrounded by the anions as well as the neutral molecules. So this whole central metal atom or ion along with the anions or the neutral molecule generally called as a ligand is considered as a coordination entity or coordination compound or a complex compound. The second terminology, that is the complex ion. How we can define the complex ion? Complex ion is electrically charged radical which consists of central metal atom or ion surrounded by group of ions or a neutral molecule, that is a ligand. So here I have taken the first example, NiNH3 6 times plus 3 complex ion. So here central metal ion along with the 6 ammonia ligand along with the 3 positive charge is considered as a complex ion. Now here I have taken the second example, FeCN 6 times 4 minus ion. So here the 1 Fe atom as a central metal atom or ion and the 6 cyanide ligand, and this minus 4 is an electric charge on this whole complex ion, and hence this whole entity is considered as a complex ion. Next terminology, that is the central metal atom or ion. This central metal atom or ion is also known as a coordination center. So the metal atom or ion to which one or more neutral molecules or anions that are coordinated is called as a central metal atom or ion. Now here I have taken again the 2 examples. The first one is NiNH3 6 times plus 2, which is a complex ion. Now in this complex ion, nickel is the central metal ion. The second example is your FeCN 6 times 2 minus ion. It is also the complex ion. Now in which Fe ion is the central ion in this complex ion. So really the metal ion which is bounded to the number of ligands or the group of ligand is the central metal atom or the ion one. Again note that the central metal atom or ion in the coordination compound act as an Lewis acid as they accept the pair of electron during the formation of a complex compound or the coordination compounds. We know that Lewis acids are electron acceptors. Let us define the next terminology, that is ligands. So what is ligands? Any atom, ion or molecule which is capable of donating the lone pair of electron to the central metal atom or ion is called as ligands. Now here again I have taken the 2 examples. That is, here I have taken the first example as an CO, CO3, NH4, then Cl. So in this complex, the carbonate, that is CO3 minus ion, and the ammonia as a neutral molecule act as a ligand. Now the second example that I have taken, that is PtCl4 NH3 2 times. Here the chlorine is in the form of a chloride ion, act as a ligand. Again the ammonia, that is your NH3 molecule, which is a neutral ligand, also act as a ligand here. In short, ligands are atom, ion or a molecule which is capable of donating the lone pair of a electron to the central metal atom. The ligands are considered as an Lewis basis, as they are capable of donating the pair of electron to the central metal ion. Lewis base is a species which is capable of donating the electrons. Now the next terminology is the coordination number. Coordination number of a central metal atom or ion in the coordination compound is total number of ligands which is attached to that central metal atom or ion. Now here I have again taken the two examples, such as, that is CO, Cl3, NH3 3 times. So here the coordination number of this complex ion is a 6, as the 3 chlorine and the 3 ammonia molecule is attached to the central cobalt ion. Next, NiNH3 4 times plus 2, which is a complex ion. Now here the coordination number of the nickel is a 4, as the 4 ammonia molecule, that is act as a ligand attached to your nickel central metal atom or ion. Hence its coordination number is 4, which is a very easy terminology. So simply here you are going to just find out how many ligands are attached to the central metal ion. That gives its coordination number. Terminology, that is coordination sphere. So what is coordination sphere? Metal atom or ion and the ligands, that is your anions or the neutral molecules, which are enclosed in the square bracket. Now it is called as a coordination sphere. That is AgCN 2 times minus, which is a complex ion. So here I have represent a square bracket, and that's in that square bracket here I have enclosed the central metal ion along with its ligands, and now that square bracket is considered as a coordination sphere. Now the next terminology, that is the ionization sphere, or it is also called as a counter ion. So the cations or the anions outside the coordination sphere is considered as an ionization sphere or a counter ion. Now here I have taken the example, that is Na in the square bracket AuN 2 times. So the entity which is outside the square bracket is a sodium ion. We know that sodium is generally in the cationic form. Hence this sodium ion is considered as a counter ion or the ionization sphere. Now the next example is CONH3 6 times Cl2. Now here you can observe that cobalt and ammonia molecule are enclosed in the square bracket. Hence it is ionization sphere, while the 3 chlorines are outside the coordination sphere. Hence it is considered as a counter ion or simply ionization sphere. So just now we have learned the two important definitions, that is the coordination sphere and the ionization sphere. Now what is the basic difference between them? One, generally the entities that are written inside the square bracket are considered as a coordination sphere, while the entities which are written outside the square bracket, okay, it is called as an ionization sphere or the counter ion. The last terminology, that is the charge on the complex ion. Charge on the complex ion is equals to the sum of the charges central metal ion or atom and their ligands, that is the anions or the neutral molecules. Now it is called as a charge on the complex ion. Now let us consider the example, the CuNH3 4 times +2 complex ion. So this +2 is a charge on the complex ion, which is generally the sum of the charges of your central metal ion and the charges carried by the ligands. Now let us consider the explanation regarding this example. So here ammonia is the neutral molecule, hence we can easily calculate the oxidation number of the copper, which is equals to +2. So if we take the sum of the charges of the central metal ion and the ligands one, so here that will be equals to, as copper will have the +2 charge and the ammonia molecule is a neutral, hence it is a chargeless molecule, hence we consider its charge as a 0. Therefore +2 plus 4 into 0, that is equals to +2. So charge on the whole complex ion is a +2. Now the second example that I have taken here, that is FeCN6 4- ion. Now this coordination compound can also be written as an Fe+2 and CN6 4- ion. So here the charge on the Fe will be equals to +2. So while we know that generally these cyanides are in the form of a cyanide anions, which is having a -1 charge. Therefore, as the 6 ligands are attached in this molecule, therefore the charge on the cyanide ion, that is your anionic ligand, will be equals to 6 into -1, which is equals to -6. So therefore the sum of the charges of the central metal ion along with the charge on the ligand, that is your anionic ligand, that is equals to plus -6, which is equals to -4. Hence this complex have the charge -4. The charge on the complex ion is the algebraic sum of the charges carried by the central metal ion and the charges carried by the ligands. So just now I have discussed the different terminology that are used in the coordination compound, which I have shown in the short summary by taking these two examples one. So I request you to take a screenshot of this one and just recall the definitions that we already learned in this video. So thank you so much for watching this video. See you in my next video.